There would be three parts. Why do we need microservices? What are microservices? And the third one, how we can build microservice architecture. To explain this, I would take a sample application. So currently, let's say you have to build a e-commerce application. How are you going to do that? So let's say first of all we need the requirements. What are the requirements? We can look at a normal e-commerce site that is available to us, let's say Flipkart or Amazon. What do we have there? So we have an option to search for product, obviously. So that would be one requirement. We, after searching for product, we might be adding the product into the cart, then later going for checkout, make the payment. So these are the bare minimum, I would say, requirements. So we can consider this as the requirement that we are going to go ahead. So because this is for a demo purpose, like this is for the explanation of microservice purpose, I'm not going to the detailed estimation of the scale, all those aspects. But just to highlight the fact, whatever we mentioned is called the functional requirements. And does that, like, is that the only requirement that we need? So let's say you have created your new microservice application. Sorry, not microservice. You have created your new e-commerce application, and you have shared it with your friends and family. You are going to the application, you are going to make an order. Everything is great. Let's say some other person also comes in and say can get all the order details. That won't be a good experience. So the service, the application shouldn't allow just anyone to see other person details. There should be some kind of mechanism to avoid that. Basically, you need a authentication username, password, all those things to secure your part. So what I'm coming to is the security. It's a requirement that we haven't explicitly mentioned, but that comes under a non-functional requirement. So like that, what other things do we need? I would say, let's say you find a good application. So sorry, you find a product that you are interested in, and you bought it and you felt it is very nice, and you shared the same product with your friend. And when your friend try to open your application, it's not available. Let's say it is showing a cute dog's picture, dog's photo. Even the people who would like dogs won't be happy when they are going to purchase something and it is not available. So this is one another issue that we need to solve. It's about availability. It needs to be available. And what are the other issues? Let's say you find an interesting product and you are add it to cart, and trying to add it to the cart, but it is keep on loading continuously. So that's also is not a great experience. So you expect things to happen quickly on a service actually. So this is regarding the latency. So you want a manageable level of latency. Then let's say you have your application, your ecom platform that you created is going very well, and you are going to conduct a sale. And during the sale, multiple people, like there is a huge influx of customer orders, and your application goes down. So that also is a terrible thing to have. So your application also need to scale effectively. So from an basic application, these are the expectations. So coming to that, so I have listed out the bare minimum level of functional requirements, then non-functional requirements as well. Now let's come to the application. So we are starting with a very minimal thing. Let's say this application is going to be used by, this is your new idea, and you are going to test it out whether it's people like it or not. You are starting very small. When you have a new idea, let's say this is a proof of concept or MVP that you want to test out. So you would have the minimum scale that you have initially, and you want to share it with other people to get a feedback or something. You're building something very small initially. So this is that application that you have the e-commerce service, you have the database that it is connecting to, and there are users coming in, everything is going fine, happy. Now you have reached a point where your application, your e-com service is kind of getting starting to get popular, people are liking it, and you want to you are a little worried that there would be bottleneck, so you want to go a little more bigger, want to reach more customers. So you have multiple options basically. You can scale, basically the requirement is to scale this application. How would you do this? Currently this e-com service, this is the service, and from the front end there is a request coming in, like all the requests are served from the data in the database. So there is two direction to take basically. Either you can go with the vertical scaling approach, you can increase the capacity of your uh, machine that is hosting the e-com service, and the database also, you can put the database in a machine that support higher specification. And or you might already know the horizontal scaling. We could have multiple instances with a load balancer and a request coming to the load balancer, then having a multiple shards in the DB. So which one is better? It, like most of the cases we would go with horizontal, but it doesn't mean vertical is bad, one is better than the other. It's just that vertical has a certain limitation. It cannot go beyond a certain level because there is limit to how big of a how big of a system that we can get in all these aspects. So at one point or another you need to go with the horizontal. So but at the end of the day, if your scale is still very regional and you don't want to go national level or international level, then you can still do a little just, let's say your initial MVP was running on your laptop or a desktop that you had in your home. You could get a better machine from AWS or some cloud provider, a bigger better machine, and put your service there and have a better database and happily serve the customers that you already have. It's not like vertically is bad, horizontally is good, it's nothing like that. But when you go beyond a certain level, you have to go with the horizontal. You would be requiring the need for going to the horizontal scaling. That's it. Now that you have a certain set of user, your e-commerce platform is popular, very popular in your region, people are using it, and you are expecting things to scale much further. You went with the horizontal scaling, everything is good. So what's the issue, right? We have the scale, we have no issues, we have all the application running in our machine, everything is fine. No, till now we haven't done anything microservices related. Now what's the issue that we have? Let's say you are growing a little more further, you have become a application that is known across the country, and you are doing some more performance improvements. You are added a caching layer to just reduce the let's say you notice that there are some certain order like products that are used frequently, so you cache the details of those products so that you can reduce the latency. So this is a little more improvement you have done, still you're able to do fine with it. So you have reached a point where you have started you have incubated a company, you have a set of employees, and you have reached a certain level of employees. And this is the point where you start noticing, again, it's not a rule or any mandatory law that you have to go the microservice way, that is like to scale. There are huge good quality services, they are still managing going fine with the monolithic architecture. So it's a call that you have to take, whether you have to. It's not a mandatory rule or anything. It's all those things depend on your business or use case. So naturally what happens is the issues that we come with the current system is like you have all the services when you go beyond a certain level for e-commerce service itself. Currently initially we started with the base level requirements like search product, add product, checkout, payment, but after a certain point you would be having multiple other services, um, maybe product recommendation engine, maybe something for last mile delivery, something for slot booking, something for warehouse management, inventory management. The application that you currently have is everything in the one place, which is shown here. So this becomes a huge application in itself. The where the problem starts is you would notice uh, how when there are multiple, you have a certain set of engineers working on the product. They would be doing improvement on the code. They would be working on a single code base. They all need to deploy their new changes, and the deployment of this huge bulk application would cause some delays, and all multiple people all working on the same code base also it's a little bit tricky situation. So you would start noticing these kind of issues. And first the deployment time is also, it won't be that quick because for this big application. And there are multiple other aspects as well. Let's say you need to add a new engineer into your team. The person has to start, for the person to start contributing, he needs to go and understand almost like the entire code. Initially itself the code setup would also would take a considerable amount of time, because there would be multiple things happening in this single monolith that you have. So the to set up the code itself, it would take some time. Then to start contributing he need to understand multiple sides of the whole thing, so it would cause further delays. And one thing that can go worse is that let's say some new person comes in, makes some changes in some remote part. Let's say there is a product recommendation engine, everything else is going fine. The product recommendation engine, you are trying to build some new recommendation system, you add some code there, it would go into production, some bug out of the blue comes up, and it is affecting, it would pull the whole application down. So issue at one part is going to bring everything down. So the initial service that you made the change, the recommendation engine, it's a good to have service. Like you go to Amazon, and Amazon or Flipkart, any e-commerce platform, you search for a product, you get it, you add to cart, you check out. That is the minimal thing. It's they do recommend products, but if one day they don't recommend products also, you won't be mad at the e-commerce platform. The basic thing, if the basic thing is taken care of, the recommendation, all those things are good to have, but that is not the minimal like basic requirement from the application. So somebody making a change in your good to have feature, if it is going to pull down the whole application, that would be a bad situation to be in. So that's one thing. So as everything is coupled together inside a single service, so whatever we want to do, we have to deal with the whole thing. That's the situation that we are in. So these are the basic issues, let's say, that I just described. Practical issues to be dealt with. All the developers would be working on the same. It's going to increase deployment time when new person and new person comes into the team. The code setup, all those things would be taking much time. It is non-friendly with agile. Like in agile we want to go cut like the requirements into small tickets, we want to go lean, we want to go complete certain set of tickets in spend multiple teams would be working on. So it is not a continue like friendly with continuous deployment, that philosophy where we want to be very agile on basically working. And a small prod issue in product recommendation can break everything. So these are the issues that we currently have with the monolithic system. So we want it to divide basically into multiple aspects. So this is the point where we have to take a decision where we want whether we want to go to microservices or not. So now let's say I'm just going back to what what we expect by the microservices before just the division part. So again coming back here, microservices. So what we basically expect is it's self-contained with clear interfaces and distinct purpose. So when we are going to divide the services, it should be cohesive. Like one service shouldn't have. I would come to that part. Okay, let me go to that part and come back here. So now in case of ecom, if we are dividing it, let's say this is what we would get. This is just a basic separation. Product search part we would be separating into a different service. The cart and checkout service, then the payment service would be different. Product recommendation engine, and there would be multiple other services. We are considering only the minimal basic set for the explanation purpose here. This would be a set of services, and you can see that the product search in, if you have a service called product search service, you are not going to add a little bit feature of cart and checkout into this has to be cohesive. Product search in itself is kind of a box we can close in the same way payment service should deal with the payment part, not let's say we feel like yeah there is a payment service, we can add some more logic from somewhere into this service. That's not the way we do divide these things. So that's the part where it is explained self-contained with clear interfaces and distinct purpose. Distinct purpose, yeah, each of our service has a distinct purpose. It's self-contained as well. So that's one point. Loosely coupled, communicate over the network. Yeah. So currently we have these multiple services. It cannot work independently. It has to communicate with each other. How do we do that? Without that, it cannot work. So these are separated out. These are loosely coupled. There is not a there won't be any function call happening from this to this, because this might be even in separate machines. This service might be deployed. So it has to effectively communicate over the network. That's why it is called loosely coupled. So the one it is communication happens over the network. And there is one more thing, you can write one service in, let's say this service can be written in Java, this can be written in Go, maybe another service can be written in different language altogether. So anything is possible because the communication happens over the network. There is no dependency or on the language that these two services has to same the same language or some anything like that. Loosely coupled, communicate over the network, that's one important part. Then these are the most important things here. Independently deployable. So what we gained when we divided these things are like the previous scenario that I mentioned, product recommendation engine, somebody is contributing to this one, that goes like there is a bug that was found. So we can do what we can do is this part itself, like all the services are deployed. Now we could do a bug fix in the product recommendation engine, and this can be independently deployed to fix the issue. We don't need to touch the other part. So that's one huge advantage. And let's say that is not immediately fixable. We can pull the service down. Even if the recommendation engine is not working, the other service can serve and serve the customers. For the period that this service is down, it there won't be intelligent recommendation happening. But for e-commerce platform, if most of the people are able to check out the it for a short duration, if there is no recommendation also people are not going to care actually. This basically is a good to have feature, but it's not a necessary feature. Now independently deployable, as I mentioned right now, then scalable part. So previously we had this previously everything is wrapped into a single thing. So most of the time what happens, there will be a lot of product searches happening, but it's not certain that all the people who search the product, it's not mandatory they would go to the checkout and buy, make the payment and buy the product. So previously we couldn't scale the search part separately. So there will be a lot of searches coming in for in the search part. They want like all the searches is not guaranteed to get converted to a checkout. So search side would be handling more like more searches basically. Previously everything we wrapped into a single thing, so we were not able to scale one part separately. So now that we have broken up the search part separately, we could do one thing. We could scale the search part separately, and just removing this, we could scale the search part separately independent of the payment service or other part. So this is one more advantage that we gain. Then maintainability part, obviously, as I mentioned previously, if there is some changes that needs to be done on one service, just make the changes on that service, do the deployment. It can be independently deployed. That's one advantage. Because we have broken down services into small units, the deployment is also not taking the time that it was taking previously. And multiple teams have a separation. Multiple when in your company, let's say you have a product search team, the cart and checkout team, payment service team, each would be independently working on their service, deploying their new features effectively. The whole thing would be working, serving the customers. So it becomes like a separation team wise. So now how to divide the services, that's a call that you have to take on. It's not a technical call basically, it depends on the business or the product you are working with. So based on multiple factors you can make this how. So there would be patterns that I would be coming to later for this purpose. So this is the main part, and the testability part. You in the deployment pipeline you can add the multiple tests, so that would be taken also automatically. So all the services doesn't have to go into deployment in a single time. Teams have the flexibility to their own deployment eventually to all work together by talking like communicating over the network. Now coming to the how do we communicate, like because each services can have its own their own set of like it may be developed on, one might be on Java, the other might be on Go. Then you would use a neutral like mechanism to communicate. Basically REST is a good option. So in microservices we have this philosophy of this thing, smart endpoints and dumb pipes. So we would keep the endpoint smart, and the communication channel basically is not so complex, and it would be simple. And the rest is a good option. Then SOAP or gRPC, these are all options that we have. And let's go back to our application. So now that we have discussed all those advantages, all our problems are taken care of, it's a happy ending, I guess. But no, like when you initially made the choice of going to a microservice, yeah, you got certain multiple advantages, but it also comes with certain pain points. So that's why I here previously initially itself mentioned the call to whether to go to a microservice, that you should like think about it whether it's worth the complexity that you are going to face in services that are serving at a very big scale. Uh, it's a good call to basically go to microservices, because even though there is higher complexity always, it would help in multiple ways. Basically structuring the development teams, all those things, teams can move independently with their feature release and continuous deployment on each module happening. There are multiple advantages that we discussed. Everything is not tied to a single monolith code, so that itself is an advantage. But if you are like you are an application that's used by your regional, maybe in a city, it is not a national level that is at a high scale, it is not worth it to move to microservice and deal with its complexity. So coming to so as like my point is, just because everybody is using microservice, it's a code, it's not necessary that you it's not a mandatory thing to be used. It depends on your how your application is, what's the scale of the application, how it is structured. So what your intention is with the application, what scale you are expecting, all those things. If we are talking about big e-commerce platforms like Flipkart, Amazon, all those, they are like working at a very high scale that requires them to use this architecture. And now we have separated out these services. Now there is a question like, how would the client know which service to make the calls? Do the client remember which service they are going to call? Let's say the Android application you have, some mobile application that you have, for product related APIs it would call this one, for some other it would call this one. But in actually a huge application, it's not going to be two, three, four, not four services. It's going to be like 100, more than 100, or like a large number of services. You cannot store all the service details on the client side. That's not a good thing to have. So you need some kind of solution for this issue. So like, we didn't have this kind of issues when we were using a monolith architecture. So we went to this structure for gaining certain advantages. Along with it, we got certain complexities. So first one, this one, where what would the client call basically. To resolve this, we brought in one another. And again, there is authentication. Where is authentication going to happen? Previously, it was all in one place. We could put the authentication part also here in the service layer itself. Now, in this service, we have divided into four services. Let's say we could put the authentication in each of the four services. But again, it is repetition of the same code, and that's not a good thing to have. So to resolve all these issues, we bring in the gateway. So this is kind of a microservice pattern to solve the issue that we just mentioned. So there would be a common gateway. The request would be coming to this one. It would be routing the request to the correct service, and the response from the request would also come back to the gateway. It is sent to the basically clients. So this is one pattern. So now that we have the gateway and we have the services separated out, it seems everything is fine. So just not one thing, even though the services are separated out, this, even though it is represented in one box, it is like multiple, we can spin up multiple instances, and there would be load balancer at this, basically at this level of service. It's just that I haven't shown it here. Now that we have the gateway and we would be receiving requests into the gateway, so everything is fine. But just one question: how does the gateway know which service to send what? So gateway should be keeping a record like a IP address of service, the machine on which service is running, and it would be sending. But again, if gateway is keeping all the IP address that it needs to send, if the service goes down and it comes back, if the machine goes down, you put another machine, the IP now changes, and how does the gateway know? So if you just keep a record of all the service in the gateway, the IP, all those things, then again it becomes hard coupling. So we initially moved from this structure, where was it? This single wrapped around code to the separate one to have loose coupling. Now, if at the gateway level we have a IP address to each of the service, then it becomes again tightly coupled. We want to avoid that. So whenever a service goes down, comes up, spins up a new instance, then that has to be, the gateway needs to somehow know that. So that's to solve this issue. It's we have another pattern in microservices. So this is the question: which service choose and what. So we bring in something called service discovery. What this does basically is, there are some survey for service discovery. Basically, it would keep track of services and basically one implementation mechanism is all this. See, there is a console or Eureka. I think Eureka is a service discovery in Spring Cloud. uh, so one of these, I don't remember exactly, Eureka or console. This basically the mechanism by which this works is uh, the each services would be updating. There will be heartbeat, so that even it would be updating their health status, all those things. The service discovery, the API gate, the gateway actually uses the service discovery to basically get the exact IP address and route the traffic to that service. So there is no hard coupling between the service and the gateway. The to find services and point it, even if services goes down and comes back, its IP changes. These things get updated in the service discovery, and this service discovery, it's a pattern or it's a service that can help the gateway in finding. In help the gateway to route the request to the correct service. So this is another pattern that is brought in into the to help us with microservices. So basically to solve the previous issue. So we just saw two patterns right now already brought in. So to get certain advantage, we move to this structure, but it also comes with its own complexity. To solve that complexity, we have set of patterns. The gateway is an example, service discovery is an example. So in the same way, there are multiple patterns. So that's how the microservices patterns comes into picture. So these are set of patterns to solve, like there will be certain set of challenges that we come into when we go to the microservice architecture. To solve these challenges, there are certain set of already built solution, so that we can call it as pattern. So what is basically, let's compare it with the design patterns we have in low level design. Basically, what does that those design patterns do? To solve a certain set of known problems, we have certain set of known design patterns that we use. Basically singleton, all those things. There are these are the standard way of solving those certain kind of problems. In the same way, in microservices, we have certain set of standard problems. Whenever you, like, you are, if your application is in Java or any other, it's a whether it's in Python, when you go to the microservice architecture, then the issues that is mentioned right now regarding the gateway service discovery, these are just common problems that you face, and to solve these common problems, there are some common solution, and that's called the microservice patterns. So these patterns, uh, the gateway is one example. Then the other one, again, what? Okay. There are many more actually. These are broadly classified into different groups. So I would say decomposition patterns. So I initiate, this is one category, integration patterns another one. So decomposition patterns deals with how you are going to decompose your existing monolith code into multiple microservices. So I had mentioned here that how we are going to split it. How would we decide whether this logic would go into one service, the other logic should go into a separate service? So there are multiple actually patterns that would help you to do this splitting up of services. What commonly we see across is based on business capability or based on this thing, just subdomains. If there is a one particular domain, you would keep it into a single service. So these are multiple ways. So decomposition patterns are set of patterns that would help you basically to decompose the whole thing, decompose this big service into small service, and there are multiple ways to do that as well. So one that I mentioned here is decomposition by business capability. That is depending on your business use case. In this case, our business was a e-commerce platform, so it required multiple services. We knew that because we are working in this domain, we know products as a service. It's we can separate it as a service, checkout service, let's say payment service. It's a cohesive service that we can separate out. So that's based on business capability or subdomain. So there are multiple patterns. It's not like only three patterns. There are more patterns. I have mentioned only three because we have a very short time. I cannot do justice like going into these things in detail in a short amount of time actually. So I would come back to this pattern later. Now we have the other set of integration patterns. So integration patterns deals with like the integration between the services. So one service that helped us to integrate this whole thing together was the gateway. So we can say that it is API gateway is one pattern of such kind. There is aggregator pattern. So aggregator pattern is one pattern where you get there are use cases where user has a request, and you have a aggregator service that go talks to multiple other services, get their data, aggregate it into a format helpful for the client. I have been repeating multiple times user, but you can treat it as a client, like let's say web client and mobile client, anything. So the aggregator service would send the aggregate the result from multiple services and send it back to the client. So basically that it is then chain microservice pattern. I'd come back to this basically, and in the integration there also there will be other patterns as well. So database patterns. So this is a whole world in its own actually. Uh, you might have noticed that after dividing the services, I haven't specified the database whether it's going to be. So there is a lot of things going on with the database in microservice. I would come back to this one. Now coming to the observability, see there is another set of patterns. So there are database patterns. Okay, so integration pattern decomposition basically deals with decomposing the microservice. Integration deals with the integration between multiple services. In the same way, database patterns kind of deals with how we are going to have database in the microservice architecture, whether we are going to provide, see in the previous where it is, yeah, in the previous structure we had a db, like it is a database engine, multiple shards, uh, talking to a e-commerce service. Now our question is, in the previous case we were keeping all the data related to the multiple services. All the data was kept in this or in these set of shards only. Now that services are divided up, there is a question arises: should we divide database also per service, or should we keep it a common database, or we do should we do something else? There are multiple questions like this. So depending on your use case, there are multiple ways to deal with this. That's so the patterns to solve our database related use cases are the database patterns basically. Then observability patterns. This is one part that is really important when it comes to microservices. Previously, we had this single service. Whatever issue we had, we could check the logs and go to the service logs and find it what is happening in the system. If we have a proper logging, let's say if we have other monitoring tools that's plugged into the single application service, everything could be found out, and there is less complexity because all the requests are coming into this single code base. Like there would be multiple instances of this obviously, but still it in a single instance only one application is running. But when we went for microservice, we took also one. Uh, we got one more level of complexity. We don't know, like, let's say there is a order that was made and the product search was done. Based on the search, user added the product to the cart, checked out, payment checked out, but there was, let's say there was a delivery service and the delivery of the product didn't happen. So we need to figure out at what point the in the overall journey things failed. So we need to go for individual services. Then it's not a practical way to like go log into each of the machine where service is running and check their logs, then log into another machine. So we need to have a proper way to aggregate the logs from these services. Then we need to have a proper way have observability. Like observability part basically deals with a look into the system. Basically, whenever there is something going wrong, we need to find what it is going wrong. And also the health check, all these things comes under this only. The log aggregation, again the first thing that I mentioned, we need to aggregate all the logs from the service into a common place that we can check easily when there's something. Then performance metrics, we need performance metrics for all the services scattered across, like all these services that are there, because it's more it gets. So you'd be asking like performance metrics, obviously we need previously as well, how the service is performing. But in microservices it becomes more important. Why? Because previously, let's say we are reaching a cpu usage level of let's say 90% something, we could spin more instances. There's a one metric that we need to monitor and spin more instances. But in this case, individual level, we have gone to microservices to gain the advantage of in scalability. See, where is that? Uh, Independently scalable part. To independently scale, we need to understand like which is serving more traffic. We see if there is, without having a proper performance, without having a proper performance like metric from surveys, we don't know which surveys to scale, all those things. So we need to know the how the cpu usage, all those things, performance is going on. Based on that, we would spin up more instances individually for services. So product search is getting heavy load, we spin more instances in the product search side. If so to basically to know whether to spin more instances or not, we need to have the information regarding observability but anyway, we are not actually in practical situation, we are not manually going and spinning new instances. These things are handled in the Kubernetes cluster. There it's automatically taken care of. And distributed tracing, basically this deals with let's say the product, as I mentioned initially, there was product search happened, checkout happened, but for the user the product didn't reach. So we need to find out where what happened. So we tracing the issue, we need this help of, basically we would be passing a trace id or id or key with the request, so that we can use that key to check through the services to understand what's going on. So you all those things I'm going through quickly. I cannot go in depth given like I have to finish this in a short time. Then there is health check part, that is the basically used in the use for health, like there is a health endpoint for services that we. So these all are patterns that we would be requiring for certain things, and there would be multiple more patterns as well. And there are some cross cutting patterns basically that is required across all the applications. Like when we go for microservices, we would have, so service discovery is one part that is coming in. Basically we have explained the service discovery here. It's a cross-cutting concern, actually it is required across services, and there are few more like this which I am not going into depth as of right now. Basically in external configuration, see, there are certain configurations that you use in our application. In the previous application that we had, we are keeping the configuration inside. Let's say there is a properties file or uh, inside here itself. But because we have multiple services which are ready to go down in time and come back, we need to have. If we keep the config some details in the application, we need to restart when we do the config update. And we basically, this is a pattern that we have a separate service and we put all the configurations inside that service, and the services would the other service would fetch the configuration from this separate config service that we have. So there are multiple patterns coming under each category that you can go in detail. Now coming back to the database pattern, as I mentioned, database per service, basically what we have is, so we were having the service discovery, everything was going looking good, and we were able to scale independently. Now coming to the database part, we could have a big database shared across all the services, but given the number of services, it's like at a big database, this shared database pattern is not a recommended pattern. Actually there are cases, it actually comes down to the use case that you are dealing with, because when your application is dealing with a very high scale and there are multiple services for individual purpose, and which itself have their own multiple instance all coming to a common DB. I was even very afraid to connect this DB to all the services given the load that is going to come. So anyway, this is a shared database pattern. It is not a very good thing to have, but there are certain situations depending on your business use case that you can go with this approach as well. But at a very high scale, it is not going to be very efficient. The database is going to be bottleneck. Then obviously there is the database per service. So we would feel like, yeah, we have the database per service and everything is okay, but there is some things that that was very easy when we had our common monolith. We had a like straightforward database. If we were using SQL, we had a product table, we had a user table, we could do the join and get the data of get data straightforward. But because now we move to database per service, things are not that simple, because of the fact that we have multiple database corresponding to each service. When we were in a single database, given that we are using SQL, we by default got the asset properties. Now that there is a there are multiple services and it is data is spread across the multiple database. The issue is we cannot straightforward do joins, or we could get the asset straightforward. We have to work with certain patterns like two-phase commit, saga, all those things. I am not going to touch those in this session, because that would in itself would require its own maybe 2 or 3 hours to go through in detail. So just because we split the database, it doesn't mean that everything is going to be easy. We would be storing the data related to each service in the database, but when there is a requirement, when we need to aggregate, we cannot straightforward do the join, because data now is separated in different databases. We have to use some aggregator pattern or some other in something else to achieve our requirement. And again coming back, and there are other patterns as well. CQRS, Saga, event sourcing. I cannot do justice going into these patterns in a short time. Basically, these are little advanced. So coming back to the structure that we have, I had missed a pattern previously, so I would come back to. So these are the things that we patterns that we use to finally get into a microservice architecture. So things become very complicated. But if your service is operating at a very high scale, this complication is justified. It's always a trade-off. Like even though there is a lot of complexity, the advantages you get is like overweights the complexity you have to deal with. But if you're a new startup creating an application, it's your MVP. If you directly go into it, let's say, yeah, microservice is the most cool thing, and let's go for microservice, that won't be a great thing to have. So it has to be like, if you have a strong reason to go, given the estimates that you have done, obviously you could with a distributed like approach, like you would go for a microservice, but it's not a mandatory go to. And the patterns also that is mentioned here, it is there is no strict rule that you have to use certain set of patterns. That all finally comes down to what the application that you are building. Sometimes shared database might also work depending on your use case. Uh, but most commonly, there is no hard rule that stating that microservice has to be built this way. But these are recommended things. And finally, when it comes to practical scenarios, most of the time what happens is, it's we cannot, let's say you are a e-commerce company, you at this point you decided, which point coming back to, let's say you are e-commerce company operating at a reasonable good manner at this point, and you are expecting a huge scale, your business is expecting to scale to international level where you should be handling a higher loads, and you decide to go with the microservices. So at this point, you are not going to shut down your company for 6 or 1 year and build microservices and going to launch the microservices again and company again. So that is not how things happen in real life. We are not going to get time to split everything into beautiful services and start everything as a new after the design is complete, everything is done. So most of the time, practically what happens is, at the end of the day, all these things are built to serve the business, like to serve the business purpose. So you cannot just to build a microservice architecture from scratch, you cannot shut out the business. So in most practical scenarios, what happens is, most of the companies, they have legacy systems. They would spend they are deciding to move to a microservice architecture, they would gradually uh, scope out some independent part of the code and separate it as services. And during the whole process, when the services are taken out from existing monolith, it is serving the customer traffic, and it is running, and it is generating revenue for the business. So this part is very rarely explained in microservice related sessions. So what exactly that is the part mentioned here. Decompose in the decomposition pattern, there is a strangler pattern. So what basically you would be doing is, you would be strangling the existing monolith, and one by one you would be spinning out, separating out new services, and start serving requests from those new services. In the meantime, you would be requiring to accommodate everything like ongoing process, you would be using multiple adapters. Adapter basically um, is to like route traffic from multiple service, let's say, to a common place. So those are services that does route certain requests from one service to another. Let's say there is a already existing service, and you scoped out some application functionality into a separate service. You put adapter in between so that uh, the traffic can go into both the services. So basically in practical scenarios you would be using multiple adapter services when the transition is happening from monolith to microservice architecture. So strangler pattern is the mostly what is happening if you are not creating a new microservices from the scratch. Mostly in big companies they have already big monoliths, so that's gradually scoped out into microservice. That's the strangler pattern. It is beautifully shown displayed here. So it's FS. We have the old system now. There are new services that are coming up. Along with the new service, old system is uh, already there, and eventually it gets completely strangled, and it would be eventually become a microservice architecture. And one the other things that we have to take care of when we are going to this microservice is that there is a huge emphasis on observability when coming to microservice, because previously everything was in same code. If you have a prod issue, it's easy to debug, it's go into the service and figure out. But now that our logic, business logic, is spread across multiple applications, you need to have multiple systems to see all the metrics, API failure count, all the incoming API graph, um, whatever metrics you could get. All those things are only going to help you when dealing with a prod issue. Now especially that now that you have multiple services and your business logic is spread across multiple services. And in the database side, mostly there would be multiple patterns that are getting used. So this is the patterns that are mostly like these are the most common things that you would be having. And these are little bit advanced, so I'm not going to that one. Basically the overall idea is CQRS. I have an image here, CQRS. So in the client level, you have the command like the write part going in one flow, it writing to the right database. Then you have the query part that is querying from the read database. Basically the write part and read part is separated out as two different uh, flows. So this is a oversimplified explanation of CQRS. It's more complicated now. Saga is also Saga comes into picture when you have this database per service pattern. But I'm not going into that depth because it's also require much time to go through. So yeah, basically this the most important thing that you need to take care is basically you need to have good observability patterns built in. Uh, Basically when you are going to the microservice architecture. So yeah, this is a short overview of microservices. Thank you.